Namaskar bachcho. Once again welcome back to the virtual class, and in the previous episode we have seen that what is an atom, how the symbol of atom is written, and we have also seen that how do the atoms exist in the universe. We have seen that the atoms exist in two different forms. One is in the form of molecules and another is in the form of ions, and elaborately we have seen how the atoms exist in the form of molecules. We have classified the molecules into two different categories. One is the molecules formed by the elements, as you can see here. Similarly, we have seen that what is a molecule of a compound. So when two or more same type of elements combine, then we get a molecule. We called such molecules as molecules of elements. For example, hydrogen, oxygen, nitrogen, these are the molecules of elements. In the later section we have seen about atomicity. So atomicity is the number of atoms joined in a molecule of an element, and in that we have seen the diatomic molecule, triatomic molecule, tetraatomic molecule and octaatomic molecule. Some examples of diatomic molecules, as we have already seen, look at the screen, you can find this. Similarly, triatomic molecule, ozone we have taken as an example of triatomic molecule, and in a tetraatomic molecule we have taken phosphorus as an example of a tetraatomic molecule. And we have seen that most of the elements which exist in a gaseous state are available in the universe in the form of diatomic molecules. Similarly, the elements which are solid in nature, we can say that the metals and non-metals, we use the symbol to represent these elements, and we have seen that those elements are monoatomic in nature. And in the later section we have seen that the molecules of compound, we know that a compound is formed by the combination of two or more different elements in a fixed ratio, and we have also seen that the smallest particle of a compound is molecule. So we classified molecules into different categories. One is the molecules of elements and another one is the molecule of compound. We have learned that the atoms or elements in the universe exist in two different forms. One is molecule and another one is ions. So about molecules we have seen in the last episode. Dear children, now we learn about ions. Ions are basically a charged species formed by losing or gaining of electrons. The ions may be of positive, the ions may be of negative. The positively charged ions are called cations and the negatively charged ions are called anions. Now, how these ions are formed, about that we will see. Dear children, you must know that atom contain three important constituents or particles we call. These particles are electrons, protons and neutrons. And about all these we will study in the next chapter, that is structure of atom. The electrons present in the atom are negatively charged and the protons present in the atom are positively charged, and lastly the neutrons are no charge. And in this, the electrons are revolving around the nucleus of an atom and neutrons and protons constitute a nucleus. So for now you understand that this is an atom in which neutrons and protons are at the center and the electrons are revolving around the nucleus. So if you take an example of an atom, the total number of electrons and the total number of protons remains same, thereby making the atom as a whole neutral. If you take a carbon atom, then you will find 6 numbers of neutron and 6 numbers of proton, and the total number of electrons will be 6. So 6 positive charge and 6 negative charge cancels each other, and the net charge acquired by the carbon atom will be 0. Suppose if an atom loses an electron, what will happen, about that we will see. By taking sodium as an example, we will try to understand how ion is formed. Now in this case you see here, sodium is the atom which has 11 positive charge, or we can say that 11 protons and 11 electrons outside the nucleus. Suppose if the sodium atom happens to lose one electron, what will be the net charge? About that we will see. Here, one electron, after removing one electron from sodium atom, what happens? On the right side you can see that total number of electrons in the sodium atom will become only 10, whereas the positive charge which resides inside the nucleus are not changing. So the total number of positive charges in the sodium atom remains the same, that is 11 in number. So here in this case what happens, 10 number of electrons are there and 11 positive charges are there. Here 10 negative charges get cancelled with 10 positive charges of the nucleus. So as a whole you can see here one positive charge is excess. So one positive charge is left in sodium atom. So this charge is acquired on sodium atom. So by losing one electron, sodium acquires one positive charge over it. It can be represented as, when sodium atom loses one electron, then one positive charge over the sodium atom we have to write. So in this example you can see that the charge is acquired by losing one electron. When an atom loses one electron and forms an ion, the ion so formed is called cation. Take another example. Here magnesium. Magnesium, the total number of positive charge is 12 and the total number of electrons are 12. So as a whole magnesium atom is neutral. When it happens to lose two electrons, what happens? After losing two electrons, you see on the other side there are 12 positive charges and only 10 negative charges. Now 10 negative charges get cancelled with 10 positive charges of the nucleus. As a result of this, two positive charges will be excess, and these two positive charges will get acquired on the magnesium atom, thereby making magnesium ion. Here in this case the magnesium ion is formed by losing two electrons. So the formation of magnesium ion can be represented as magnesium atom when loses two electrons. Here magnesium 2 plus, here 2 plus indicates that two electrons are short. Now we see another type of ion, that is anion. Dear children, anions are formed by gaining of electrons. When an atom gains electron, it gets some excess negative charge on it, and these excess charges are acquired on the atom, thereby making an ion, thereby making a negatively charged ion, and these negatively charged ions are called anions. By taking an example of fluorine, we try to understand how anions are formed. If you see the number of electrons, protons in fluorine, it is found that in fluorine atom there will be 9 positive charges and 9 electrons carrying 9 negative charges. Now in this what happens? It happens to gain 1 electron. As a result of this, on the other side you can see that the total number of electrons are 10 in number, whereas the total number of protons, that is positive charges, are 9 in number. So 9 positive charges get cancelled with the 9 negative charges which are revolving around the nucleus, and we can see here that 1 negative charge is excess. This extra negative charge gets over the fluorine atom. So this can be expressed as fluorine by gaining 1 electron. The excess electron what we have seen here will get over the fluorine atom, thereby making fluorine ion. F minus we have to write. Similarly, if you see the example of sulfur, the total number of electrons present in sulfur is 16 and the total number of positive charges are also 16. So as a whole sulfur atom is neutral. By gaining 2 electrons, what happens? Here total number of electrons will become 18 and the total number of protons are 16. So the 16 protons get cancelled with 16 electrons. As a result of this, 2 excess negative charges are there over the sulfur atom. so sulfur ion will be formed. So the formation of ion can be represented as sulfur by gaining 2 electrons. Here we get sulfur ion, so S2 minus. So the ion is formed by gaining of electrons, so we call it as the ion so formed is anion. So this way positive and negative ions are formed by losing or gaining of electrons. And you must know that the cations are formed by losing of electrons and anions are formed by gaining of electrons. So we can say that the ions are formed by losing or gaining of electrons, and the charge over it can be understood in terms of cations and anions. Now we will see about the polyatomic ions. We have seen the molecules of compound. What will happen if a molecule loses or gains an electron? Same thing will happen if a molecule loses an electron, again the molecule will get positive charge. If a molecule gains an electron, then it acquires negative charge and we call it as anion. Now the question is, why does an atom loses or gains electron? Dear children, each and every atom must exist in the universe in stable configuration. They need to be in a stable configuration. This stable configuration is achieved either by losing or gaining of electrons. What is this stable configuration? About that we will learn in the next chapter. For now you understand that in order to get a stable configuration, an element needs to lose or gain electrons. So only the electrons lose or gain electrons and itself acquires some charge on it. Now we see about polyatomic ions. Dear children, see here, these are the ions. You can see here NH4 plus. We call it as ammonium ion. In the earlier section we have seen that an atom loses or gains electron and acquires positive or negative charge. But here in this case you see NH4, it is no more an atom, it is a molecule. Here as a whole if you see, 1 atom of nitrogen and 4 atoms of hydrogen are there. As a whole it has 1 positive charge. Such a ion is known as polyatomic ions. Here poly refers to more than 1. When charge is acquired on a molecule having 2 or more atoms combined in a fixed ratio, such an ion is known as polyatomic ion. This polyatomic ion may be cation, this polyatomic ion may be anion. So some of the polyatomic ions, that is cations mentioned here, ammonium ion is an example of polyatomic cation, and other example you can see polyatomic anions. Sulfate SO4 2 minus, here sulfate is a polyatomic anion. Hydroxyl ion OH minus is also here 2 atom you can find. So this also polyatomic ion. So this way various other examples are given here. Now we will see how to differentiate between the ions formed by atom and the polyatomic ions. Dear children, if a single atom loses or gains electron and acquires some charge, we call it as simple ions. Whereas 2 or more different atoms form a cluster and a charge is acquired on the cluster of atoms, we call it as polyatomic ions. Here poly means 2 or more than 2. Here 2 or more different atoms are usually combined to form a cluster, and over the cluster we can see some charges. If the cluster of atoms have a positive charge, we call it as cation, and if it has a negative ion or a negative charge, we call it as polyatomic anion. So you can see on the screen some of the polyatomic anions and polyatomic cations. So the same is given in your textbook. You can go through and identify which of the following are polyatomic cations and which of the following are polyatomic anions. And I hope you understood what is ion and how these ions are formed, classification of ions, simple ions and polyatomic ions. Now we see about ionic compounds. Children, Ionic compounds are those compounds which are formed by ions. Take an example. Here sodium chloride is an example of ionic compound. If you observe it carefully, then you will find the ions are present in the sodium chloride. This sodium chloride is the compound which we use in our day-to-day life. What is that compound? The common salt which we use in our home is sodium chloride. So the sodium formula of sodium chloride is Na plus and Cl minus. Here you can find that sodium is in ionic nature and chlorine is also in ion. So these ions make up a compound. The compound is called ionic compounds. Likewise, various other examples are given. These are the examples of ionic compounds. So the necessary condition for an ionic compound is they are formed by the ions, and in the chemical formula you will find these atoms are found in the form of ions. Due to strong interionic force of attraction, they held together make up a compound, and the compounds so formed by these ions are called ionic compounds. So far we have seen the ions, how ions are formed and what are the various types of ions. Now we will see about molecular mass, and in the earlier section we have found out how relative atomic mass of an element could be found out by using the standard unit. We used 1/12 the mass of carbon atom has been taken as a reference for finding atomic mass. The same way we can find the relative molecular mass of compound. Dear children, by taking an example, we try to understand how relative molecular mass could be found out. At first, I have taken an example of hydrogen molecule. The molecular formula of hydrogen molecule is H2, and the relative molecular mass, how it is found, about that we will see. We know that hydrogen molecule, each hydrogen molecule has 2 atoms. To find the molecular mass of hydrogen, we need to add all the relative atomic mass of the molecule, and finally we will get the total relative molecular mass of hydrogen. Here 2 atoms are there. If we know the total relative mass of hydrogen atoms present in the molecule, by adding up all the relative atomic masses, we will get the molecular mass of a particular compound or a molecules of element. Here in this case, in hydrogen, the atomic mass of hydrogen is 1 U. Total relative mass of hydrogen will become 1 plus 1 is equal to 2 U. So the molecular mass of hydrogen will become 2 U. Now we see how molecular mass of oxygen is found out. Here oxygen is O2. Here we have 2 atoms. We know that the relative atomic mass of oxygen is 16 U. So here 2 atoms of oxygen combine to form oxygen molecule. So the total mass of oxygen molecule will be 16 plus 16, which is equal to 32 U. Now we see how molecular mass of the molecules of a compound could be found out. Take an example of carbon dioxide. Here carbon dioxide molecule, you can find 1 atom of carbon and 2 atoms of oxygen. We know the atomic mass of carbon is 12 and the atomic mass of oxygen is 16. So here carbon, the atomic mass of carbon is 12. Atomic mass of each oxygen atom is 16. So 2 into 16. Here we will get 12 plus 16 into 2 is 32. Here 12 plus 32. Finally we will get 44 U will be the molecular mass of carbon dioxide. Similarly, we can take another example of water. In water you will find 2 atoms of hydrogen and 1 atom of oxygen. We know the relative atomic mass of each hydrogen atom is 1. So 2 atoms are there, 2 into 1 plus what else is there? Oxygen atom is there. 1 oxygen atom will have atomic mass of 16 unit. 2 plus 16. 2 plus 16 is 18U. This way molecular mass of various other compounds could be found out by knowing the relative atomic mass of the constituent elements. Children, I believe that you will easily find out the molecular mass of different compounds and molecules of elements. Children, now we learn about chemical formula. What is a chemical formula? Chemical formula tells us the actual composition of elements present in a compound. So by the molecular formula of a compound, we can easily find out the type of atoms or the elements present in a compound, or the total number of elements present in a compound and the ratio of the elements present in a compound. How a molecular formula of a compound is represented, about that we will learn. Children, to know how a chemical formula is written, we should have the basic knowledge about the valency. About valency, however, you will study much about valency in the later chapter, but for now you should know what is the valency. Valency is the combining capacity of an element through which it combines with other elements to form compounds. For example, here carbon dioxide, CO2, from this we can easily say that in carbon dioxide compound or a molecule, one atom of carbon and two atoms of oxygen. So by knowing the chemical formula, we can easily understand the number and kinds of particles or the elements present in a compound. Now we will see how a combining capacity of an element could be found out. By using simple techniques also, you can easily remember valency of an element for a long time, but for that you must know about its atomic number. If you know the atomic number, from the atomic number we can easily find out the valency of an element. How it is done, about that we will see. There are certain rules to be followed to find the valency from atomic number. Firstly, you have to see the atomic number, whether it is greater than 9 or not. If it is greater than 9, we have to subtract it by 10. While doing so, whatever the answer we get, from that we can identify the atomic number. Atomic number of magnesium is 12, which is greater than 9. If the atomic number is greater than 9, we have to subtract it by 10. So by subtracting 12 by 10, we will get 2. So whatever the answer we get, firstly we have to see whether the answer after subtracting it by 10 is 1, 2 or 3. If it is so, then the answer will be the valency, that is 1, 2, 3. Here in this case, 12 minus 10 will give you 2, so the valency of magnesium will be 2. Another example we will take, calcium. Calcium is having atomic number 20. So 20 is greater than 9. Once again we have to subtract it by 10. While doing so, we will get the answer 10. Here the answer is not 1, 2 or 3. If it is so, then we have to make the answer after subtracting it by 10, whatever the answer we are getting, that has to be converted into 8. Here we have got 10 as the answer after subtracting it by 10. So the 10 has to be converted into 8. To convert 10 into 8, we need to subtract it by 2. Here 2 is being used to convert 10 into 8. So the number which will be used for converting it into 8 will be the valency. So here in this case, calcium, we have used 2, so 2 is the valency of calcium. Another example we will take. The atomic number of fluorine is 9, which is not greater than 9. If it is so, then we have to follow the second step, second rule, that is any number which is less than 10 has to be subtracted by 2. While doing so, whatever the number we get, if it is 1, 2 or 3, then the number will be the valency. If it is not, once again in the earlier case what we have done, it has to be converted into 8. For converting it into 8, whatever the number we use, that will be the valency. Here in case of fluorine, the atomic number is 9. Firstly, we need to subtract it by 2. While doing so, we will get 7. This 7 has to be converted into 8. For this, we need to add one number. So when we add 1, we will get 8. So the number 1 is being used for making the 7 into 8. So the valency of fluorine will be 1. This way you can find valency of the elements ranging from hydrogen to calcium, that is 20 elements. Valency you can find by using this simple step. Now we will see how molecular formula of different compounds are found by knowing the valency of or the combining capacity of these elements. So combining capacity of various elements are given in the table, or in the textbook also you will find the valency of different elements. By knowing the valency of these elements, you can easily find the molecular formula. You can form the molecular formula of various compounds. How it is done, about that we will see. Now we will see how chemical formula of a compound is written by knowing the valency. Firstly, we try to find the chemical formula of sodium oxide. Dear children, here in sodium oxide you can see that sodium is one element and oxide is another element. To write the chemical formula of sodium oxide, the symbol of the constituent elements of the compound needs to be written. Here sodium, the symbol of sodium is Na, and here oxide means oxygen, the symbol of oxygen is O. The second step is you have to write the valency below the symbol. Here the valency of sodium is 1 and the valency of oxygen is 2. Now thirdly, what we need to do is, here we have to cross over the valencies, so that here sodium is pointed up to the valency of oxygen, that is 2, and oxygen is pointed up to the valency of sodium, that is 1. So the next step is sodium we have to write, and sodium is pointed towards 2. So here subscript we have to write 2, and oxygen is pointed towards 1. So here 1. We need not to write 1, so we can leave like this. So the chemical formula of sodium oxide is Na2O. Now we see how chemical formula for magnesium oxide is written. Here magnesium oxide, from this you can easily know that the symbol of magnesium is Mg and the symbol of oxide, that is oxygen, here you have to write. Magnesium has the valency 2, so below magnesium we will write the valency. Similarly oxygen also has the valency 2. So the next step is we have to cross over the valencies. By crossing over we will get like this. So here you see Mg2 and O2. Now the formula of magnesium oxide is not Mg2O2. After writing the valencies below the element, one more thing to note here is that we have to see the valencies. If both the valencies are same, then the valencies are to be cancelled out. So upon cancelling we will get here 1 and here also we will get 1. We know that wherever 1 is there we need not to write. So the chemical formula of magnesium oxide will be MgO. So this way the chemical formula of magnesium oxide can be written. Dear children, I believe that you understood how molecular formula of different compounds can be written by knowing the combining capacity or valency of different elements. Now we learn how formula of ionic compounds are found. In the previous section we have seen how chemical formula of a molecule of a compound could be found out. In the similar way we can find the chemical formula of ionic compounds. We will also see polyatomic ions. Firstly, we will take the example of sodium sulfate. Here in sodium sulfate, you can see that the first element is sodium. So we write symbol of sodium. Here sulfate is a polyatomic ion. We write it as SO4 2 minus, right? So here we write Na plus. We know that the valency of sodium is 1 and valency of sulfate is 2. After writing the symbols and the valencies, we need to cross over the valencies. So by crossing over we will do like this. The charge over the atoms should not be written. Here sodium we have to write like this Na, and it is pointed up to the valency of sulfate, that is 2. So here we will write Na2 as we have already done like this in the previous section, and sulfate is pointed over 1. So when it is pointed over 1, we know that 1 we need not to write. So simply we write SO4. So the chemical formula of sodium sulfate will be Na2SO4. Now we see how chemical formula of calcium hydroxide is written. So in calcium hydroxide we find calcium is one element. The symbol of calcium is Ca, and hydroxide ion is present here, OH. Here the valency of calcium is 2 and the valency of hydroxide is 1. So while crossing over we do like this, and for writing chemical formula we write calcium is pointed up to 1, so 1 we need not to write, whereas here hydroxide ion, here hydroxide is present, hydroxide is pointed up to 2, so here we write OH. Here one more notable thing is this 2 is meant for O and H. So in such case what we need to do is we have to put OH in parenthesis, and below it we have to write 2. So the chemical formula of calcium hydroxide would be CaOH twice. Children, the ions may be of monoatomic or polyatomic ions. Monoatomic ions are those ions in which a single atom acquires charge, whereas polyatomic ions are those which have a cluster of atoms and together they acquire a charge. And how formula of these monoatomic and polyatomic ions are found, about that we will see. Hope you understood how the formula of ionic compounds could be written. Now we see formula unit of ionic compounds. Dear children, ionic compounds do not exist independently like molecular compounds. Here the ionic compounds form a huge structure, as you can see here, millions and millions of ions combined by interionic force of attraction, and as a whole if you see, the compound will be very huge. The simplest combination of ions that produces an electrically neutral unit is called formula unit, and mass of this unit is called formula unit mass. For example, sodium chloride is a ionic compound. The unit mass is sodium and chlorine are the simplest combination which gives a neutral unit, Na plus and Cl minus, and mass of these sodium and chloride ions are taken together, and the mass of sodium and chloride ions together give you the formula mass, and we call it as formula unit mass. Based on today's learning, I would like to give some easy home assignments which you can practice at home. So here is your home assignment. Children, that's all we have for today's class. In the next episode, we will be seeing another important concept, that is gram atomic mass, mole concept, and some of the numericals related to mole concept. Till then, keep learning, take good care of yourself. Bye.